Hey everyone, welcome to Ladboy Coding. Today we are going to solve problem 767, Reorganize String. And we can see lots of companies like this problem. So given a string S, we need to check if the letter can be reorganized so that two adjacent character is not the same. For example, if the string is AAB, then one of the answer is ABA because 2A is not adjacent to each other. But if the string is AAAB, then one of the arrangement is ABAA. Then 2A is adjacent to each other, so we need to return an empty string. So how do we solve this problem? The solution is very similar to a problem called task scheduler. This is an also greedy problem. We need to use a greedy approach. So let's walk through our algorithm. So given a string, we need to count the frequency of each character. And in this case, A appear twice, B appear once. And then we use a max heap. We put the character according to the frequency. And the character that have the max frequency is on the top of the heap. Why do we do this? Because we need to put the most frequently appeared character in the first to avoid duplicate character that can be put adjacent to each other. So let's walk through our algorithm. First, we have A2, B1, and then we put these two data into the heap. We also need to have a temporary list. So for every iteration, we get a number from the heap. And then let's also create a result array. So result. Every time we get an element from the heap and we append the character into the result. And then we minus the number of frequency. If it's still larger than 1, we need to put it back into the heap. And then we get number B, character B, and we put B into the result array. And then we know that there's no B in the original strings, so we do not need to put it back into the heap. And then in the next iteration, we just get the data A and then put it into the result, and we minus 1. So in this case, there's no data in the heap. There's no data in the temporary list. We just need to return the result. So for example, if A appears 3 times, so in this case, we would still have an A in the heap. We get it from the heap and put it in the temporary list. And then we put A into the end of the result array. And we can check that the last element in the list is equal to A. So we know that it is impossible. So we can just return an empty string. So this is the algorithm. Now let's code it. Let's do the first step. Let's print our dict. So if the character is in the dictionary, we just add 1. Otherwise, we know it appear once in the string. So yeah, it's correct. And then let's first print these two data. This is a way to iterate the Python list. Yes, AB, A to B1. When using the function heap push, it can maintain a structure of the heap automatically. So yeah, and then let's print heap. Oh, heap. We also need to initialize our heap. Print heap. Yes, and we can see that. But notice that we need to use it as a max heap, but by default, Python gives us a min heap. For example, so heap. First, let's heap push heap 1 and 2. So now if we do heap pop, it will give us 1 because 1 is the smallest element in the heap. Yes, but how do we get 2? We just need to put -1 and -2. So now it will give us -2. So by multiplying -1, we can use min heap as a max heap. So yeah. And how do we get 2? We just multiply -1 again. So yeah. Oops. We need to convert. Wait. Oh yes. Yes. Cool. So let's create a result array. And while there is element in the heap, so every iteration will run 2 times. because two adjacent characters should not be the same. So now we get an element from the heap. Notice that we multiply -1. We need to multiply here to get back to a positive number. Or to increase the readability. -1. Yep. Now here we need to append it. I mean, here we need to append it into the result array. But before doing that, if there's element in the array and the character is equal to the last element, we just return an empty string because two adjacent character is the same. And then if there's no data in the heap and there's no data in the pending list, we just break and return the result. So here, for example, if the data is A, B, A, we need to use the join function to get a string. Yes, here. So else we put everything from the pending list back into the heap. Yes, let's run it. Oops, here. Yes, and let's print the heap. And we can see that this is the original heap. And then in the first iteration, we process A and B. And then in the next iteration, we process A. So we get the result. Let's try another test case. We know that in this iteration, here, 2A becomes adjacent. so it returns an empty string. Yep. So let's submit our code. Okay. Now let's analyze our time space complexity. The time complexity is linear with respect to the length of the string. And the space complexity, we use a heap, but at most there is 26 elements in the heap. So we can assume it is constant. Okay, everyone. Thanks for watching. The code is in the description and comment below. If my solution helped you, please feel free to subscribe and comment. Thank you very much. Bye-bye.